Hello, algebra students. We're going to put together the work that we've done so far with radicals all into one day. So we've worked a lot with simplifying radicals, and our last lesson was about multiplying radicals. We just need a little bit more work with all of that together to make sure that we're feeling very comfortable with it. So these first couple problems are just purely simplifying radicals, making our trees and then finding pairs. I don't even have any cube roots today. It's all about square roots. So for 175, personally, when I think about a number like that, I'm thinking money. If I have $1.75, I could figure out how many quarters that is. 25 goes into this. 25 times 7, because if you had 7 quarters, that'd be $1.75. The 25 can split up to be a 5 and a 5 pair. That breaks out. The 7 got left over. This stays inside a radical, and it's done. For 72, lots of ways to break this one up. Personally, I jumped to 36 times 2 because 36 is a perfect square. However, I'm guessing that most students are going to go with 8 and 9. 8, I'm hoping everybody's feeling comfortable enough with 2, 2, 2, so 2 times 4 and then splitting up the 4. The 9 is going to be a 3 and a 3. And remember, square roots, we need pairs. So I have a pair of 2s, that breaks out, becomes a regular 2. I have a pair of 3s, that breaks out, becomes a regular 3. This is left over. Didn't have a partner to break them out, so he's stuck inside. So I would multiply those outside numbers and get 6, rad 2. When I have a number out in front of the radical, just multiplies with whatever else breaks out of the radical. For 18, you could go with 6 and 3, or you could go with 9 and 2. Again, I really like to use perfect squares as much as possible. I like 9 and 2, but if you use 6 and 3, it'll work just fine. So this will be a 3 and a 3 pair. The 2 doesn't have a partner, stays inside. So I have 6 on the outside. I have 3 on the outside now that broke out, and I have my 2 left over. So that'll be 18 rad 2 for my answer. In number 4, the 3 that's on the outside happens to be negative. I'm going to say, just like on all the other problems, don't even worry about that negative 3 right now. Worry about the square root of 75. Again, I would absolutely go with 25 on this. 25 times 3. So there's my 5 times 5 pair. So I had this negative 3 on the outside. I break a 5 to the outside. This is the only thing that didn't get to break out. It stays inside. And then negative 3 times 5 is going to be negative 15. Rad 3. Multiplying radicals, like our last lesson. When we have these kind of problems, you can certainly multiply the 5 times the 15, which will get you 75. We just worked on a 75, so you'd be able to do that. I'm going to also show you or remind you that you don't have to put those two together to make 75. I'm going to do this problem twice. So I'll have the 5 and the negative 4 that were both on the outside. I can put the 5 and the 15 together, multiply by negative 75. And then I would start splitting that up, and I would have 25 times 3. Remember, you could have also split that right back to a 5 and a 15 if you wanted to. And then here is my pair of 5s. That's going to break out. 3 stays inside. So I had a 5, and I had a negative 4, and then I'm going to break out this 5, and I have this 3 left over. So this is going to be a negative 100. Rad 3. Now for me personally, I don't tend to put the 5 and the 15 together to make a 75 because, as I said in this problem, I could have split that 75 right back into a 5 and a 15. I don't think that's usually the split that most students make, but you could, and then it kind of wasted a step if you do it that way. Instead, I would look at this 15 and say, well, I could make that a 5 times 3. Remember, the 5 and the 3 that I just wrote are still underneath that radical because that 15 was in a radical. So that means that this 5 and this 5, which are both under radicals, can pair up. So I had a 5 on the outside. I had a negative 4 on the outside. I can break another 5 to the outside. And there's my leftover 3. That second way that I did it, that's what I tend to do. It saves a little bit of time, but not a significant amount. So if that bothers you, if you're not sure if you can circle things or not, just do it the way that I did with the first one. In number 6, I'm also going to do this problem twice. You could certainly multiply these two together and we'd have the square root of 24. And then again, like I just said in this last problem, I could totally see some people saying, oh, then I'm going to do 6 times 4, which now didn't save me any time because I'm right back to exactly what I started with. The 6 is going to be a 3 and a 2. The 4 is a 2 and a 2. So here's a pair that breaks out. The 3 and the 2 go back together to make this. If you had just made your trees right away, square root of 6, square root of 4, instead of multiplying together, get 24, you could have the 3 times 2 and the 2 times 2, and you get your 2 rad 6. Same thing. So I was going to do this one twice, and I'm actually going to do it 3 times. Here's the other way. Square root of 4, that's a perfect square. The square root of 4 is just 2. It breaks out. Square root of 6, that's just a 2 and a 3. There's nothing that's going to simplify there. This problem you could have done with no work at all. You could just write your answer on this problem if you realize that the square root of 4 is just 2. For number 7, rad 5 times rad 20. Neither one of those are perfect squares, so it's not like this where the 4 was a perfect square. You know that there's a match that we'll get in there if we would just split up the 20 to be a 5 and a 4. However, on this problem, this one in particular, I would say let's put it together into one number because 5 times 20 is 100, which is a perfect square, which doesn't need a tree because you guys know that 10 times 10 is 100. The square root of 100 is just 10. Just happens to not have any radical parts left over. In number 8, you could certainly multiply the 2 times the 10 together to make a 20. Or I could split up the 10 to be a 2 and a 5. Remember, the 2 and the 5 that I just wrote are really underneath that radical because the 10 is underneath the radical. So that means that this 2 and this 2 can pair up. This 2 was already on the outside. That pair that I just circled breaks to the outside. The 5 that's left over didn't have a partner to break them out. 4 rad 5. The square root of 12 times the square root of 15. Now, 12 times 15 is 180. It's not a perfect square. You could certainly multiply them together if you wanted to. But again, I will say that I prefer to just make separate trees and know that all of it is underneath those radicals, so I can circle anything from either one of those trees. So 12, I'm going to go with 4 times 3, and the 4 will be a 2 and a 2. There's a pair. The 15, I'm going to go with the 3 and a 5. By the way, I don't care if you write it 5 and 3 or 3 and 5. I wrote it like this so that I can circle my 3's right next to each other. Remember, the 4 is not the end of a branch. The 4 doesn't get left over. The 4 got broken up into those other 2's. So I have these 2's that broke out. I have these 3's that break out. And then my leftover stuff is just that 5. 6 rad 5 is my answer. Number 10, some people make this way harder than it needs to be. You could certainly multiply these two together. Square root of 2 times the square root of 2 would be the square root of 4. And we all know the square root of 4 is just 2. Here's the even easier, if it's possible, the even easier way to do this is I have a pair of 2's. They are both under radicals. They break out and they just become a regular 2. And these last two problems, distribution. Now, number 11 has radicals in all the parts. Both of the things inside the parentheses have radicals, and the thing that I'm distributing has a radical. So, just multiplying here. Square root of 3 times the square root of 10 would be the square root of 30. Plus, let's just multiply everything exactly the way it is. Here's my 5 that's on the outside. The square root of 3 times the square root of 3 is the square root of 9. Now, the 9 part, that's easy, right? 3 and 3, that's going to be a pair. It's going to break out. We're going to be happy. That part's going to be 5 times 3, which will turn into a 15. 30, kind of like in my last lesson when I was talking about 42. People are like, oh yeah, there's got to be a pair there. 30 is 6 times 5. Here's a 2 and a 3. And there's no pairs. Now, this plus sign is kind of like a do not cross this line. I can't circle anything from that 30 with the stuff with the 9 because of the addition. If it was multiplication, it's all fair game. Addition, totally separate parts. So this doesn't clean up at all. That's just going to stay as the square root of 30. Now, to kind of make my answer look a little bit nicer here, I'm just going to have the square root of 30 plus 5 times 3 is 15. And again, if 15 is not in a radical, you cannot add those two together and make it a 45 or the square root of 45. That's just your answer right there. That's the best we can do is the square root of 30 plus 15. In number 12, you have some options, but again, to keep this easy, I think, let's just multiply, not try to do the separate trees and all that. Square root of 15 times the square root of 10 is going to be the square root of 150. The square root of 15 times 4, remember the regular number goes out in front, so it'll be 4 rad 15. Now, I've said this a whole bunch of times. You know that I don't really like to split it right back to exactly what I started with, but 15 and 10 is the thing that makes the most sense to me. 15 times 10, here I'll have a 3 and a 5. Here I'll have a 5 and a 2. And again, notice I just wrote the 5s next to each other so they're easier to circle. This 15, remember, there's a plus sign, can't cross. 3 and 5, oh, there's no pairs. That one doesn't simplify at all. So in the first part, the 5s that we paired up break out. The 3 and the 2 go back together. There's my plus sign. Yeah, and this didn't do anything for us. We can basically ignore that and just say, oh, that's 4 rad 15. And again, if the radicals don't match, you cannot add those two together. You can't try to make that into one thing. Rad 6 and rad 15 don't match. They're like X's and Y's. That one's just don't. So today's worksheet, simplifying and multiplying radicals, nothing new today. It's all just review of all the stuff that we've been doing so far with radicals. There's an answer key in Schoology for you to use to check, and make sure you take the formative. Let me know if you need any help.